Hello geometry students, my name is Emigh, and this video is our discussion on section 9.3, trigonomic ratios. I want to start with an example just so you can see how trigonomic ratios are used to find missing parts of a triangle, and then we'll talk about the definition of the trigonomic ratios and break it down. Okay, a surveyor took the measurements shown in the figure, used trigonometry to determine how far it is across the lake, round to the nearest yard. Okay, so we have a right triangle that's been constructed here. The surveyor measured along the ground 630 yards and then used some kind of instrument there, it looks like, to measure this angle to be 40 degrees. With just those two measurements, 630 yards and the 440 degrees, we can use trigonometry to find all the missing parts of the triangle there. And the one we are being requested to find is this side length right here. So it's the distance across the lake. Okay, so as you guys know, it's our first goal to write an equation with the unknown variable in it. Okay, so the equation is going to have a trigonomic function called tangent. Tangent of, then we say 40 degrees, is equivalent to the length of the opposite side over the length of the adjacent side. Okay, so this is the ratio right here, and this is the trigonomic function, and that's our angle measure. All right, so what you want to do is go to your triangle. I like to circle the angle that I'm working from. Then I draw an arrow to the opposite side, and it looks like the opposite side length is our unknown A. So instead of OPP for opposite, we're going to write an A there. And the adjacent side would be the 630 yards. So it's going to be A over 630. Notice that the third side of the triangle, the hypotenuse, is not used when we're using the tangent function. Tangent is dependent on the opposite and adjacent side lengths, not the length of the hypotenuse. Okay, so let's see what that line looks like after substituting A and 630. So there we go. We would read that tangent of 40 degrees equals A over 630. All right, now that equation only has one unknown, which is exactly what we want. We'll isolate that unknown using our algebra skills and move from then round to the nearest yard. Okay, so I do want to point out that this TAN, it looks like there are more variables in this equation than there are. But remember that TAN stands for tangent, and that is the function. It's not an unknown variable. This is our only unknown variable right there, the A. So that's what we're going to try to isolate. All right, so to isolate that A, we're going to need to we need to get rid of this divided by 630. We get rid of A divided by 630 using multiplication of 630. And so multiplying both sides of the equation by 630 looks like this. Those 630s cancel out, leaving A as the only thing on the right side of the equation, which is what we wanted. And now we have 630 times tangent of 40 degrees is equivalent to our unknown variable A. All right. This is the exact value of A, but we have been asked to round that value to the nearest yard. So at this point, and not before, I want you to pick up your calculator. The two most common units used to measure angles are degrees and radians. So you're going to want to make sure your calculator is in degrees. You can check that by hitting mode. It's at the top center of mine. Find it on your calculator, and then make sure you have degrees selected. Some calculators say DEG instead of RAD for radians. All right, so once you have your mode in degrees, and the reason we know to use degrees is because of that symbol right there, then we can go ahead and type this in. Okay, so we're going to type it in from left to right, 630 Now you can hit the multiplication key if you want to. The operation between 630 and tangent is multiplication. Or you can just hit the tangent key, T-A-N. Mine opens parentheses. Then I do the 40 and I'll close those parentheses. Then I hit enter. So I got 528.6327 and so on, which means rounded to the nearest yard, the distance across the lake is approximately 529 yards. Okay, so I wanted to do that example just so you can see how the trigonometric functions are used to help us find missing pieces of a triangle. It's really, don't let yourself get overwhelmed by these trigonometric ratios. Just try to remind yourself, if it helps, that the strategy is the same. We need to write an equation. We need that equation to have one unknown. We then need to use our algebra skills to isolate that one unknown, and then we can use our calculator if we're requested to approximate. Okay, so now let's go ahead and talk about what the trigonometric ratios actually mean. So the word trigonometry is derived from ancient Greek and means three-angle measurement or triangle measurement, because we know that triangles have three interior angles. So trigonometry is the study of triangles and their measurements. Three angles, three sides. Recall that any two similar right triangles, let me sketch that so you can get any two similar right triangles. So I'm just going to sketch a couple similar looking right triangles so you can visualize that. Okay, recall that any two similar right triangles have equal angles, right? All the corresponding angles are congruent. So like this, 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 this. And now here's the key. The ratios of their corresponding sides are equivalent. Because these similar right triangles have equal ratios, we call these ratios trigonometric ratios, and we give them special names. Okay, so the ratio of, I'll use A, B, and C, and then we'll use, let's go with like E, F, G. And we know that A is to E, the same as B is to F, the same as C is to G, okay? And we're going to see the special names on the next slide. All right, trigonometric ratios. Let triangle ABC be a right triangle with acute angle A. All right, so we need those conditions to be met. We need a right triangle, and we need acute angle A. Now we have our first equation. Sine, so the trigonometric function sine of that angle A is equivalent to, now here's its ratio, length of the opposite leg over the length of the hypotenuse. And in this figure, I'm going to circle that A. I like to circle the angle that we're working off of, because if it was sine of B, it would be different. So sine of A, the length of the leg opposite of that is the lowercase a, and the length of the hypotenuse is C. And that's why you have A over C. All right, let's do the next one. Next trigonometric function is cosine, often abbreviated COS. Cosine of angle A, okay, so we're going from angle A again, is equivalent to the length of the leg adjacent, that would be this leg here, over the length of the hypotenuse. And that is why you see the B over C right there. All right, third one, tangent, often abbreviated TAN. Tangent of angle A is the, let's circle A, length of the opposite leg over the length of the adjacent leg. okay? And that is why you see the A over B right there. All right, I'm going to rewrite these in a way that you'll more often see them. Sin angle A is equal to opposite over hypotenuse. That's this first one here. It's abbreviated. The next one would look like this. Cosine, COS, of angle A is equal to adjacent over hypotenuse. And the third one is often abbreviated as TAN for tangent of angle A is equivalent to the opposite side length over the adjacent side length. Okay. I'm going to abbreviate these now even a little further. Sometimes you'll see sine of angle A is equal to O over H, opposite over hypotenuse. Cosine of angle A is equivalent to lowercase a over lowercase h, adjacent over hypotenuse. And tangent of angle A is equivalent to O over A for opposite over adjacent. Okay, so this is the more spelled out, where everything is spelled out for you, and then you see some abbreviations below. Okay, so let's practice writing trigonometric ratios now. We're asked what the sine, cosine, and tangent ratios are for angle T. Okay, so if you want to use my technique, I like to circle the angle T first. Okay. I am going to go ahead and draw 3 arrows. And I'm going to label those with H, A, and O. This is the hypotenuse. This is the side adjacent to it. And this is the side opposite of angle T, of course. All right, so our first trigonometric ratio is sine of angle T is equivalent to opposite over hypotenuse. So opposite is 8, hypotenuse is 17. So the ratio would be 8 over 17. Sine of T is equivalent to 8 over 17. Next one, cosine of angle T is equal to adjacent over hypotenuse. Adjacent is 15, hypotenuse is 17. So it would be cosine of T equals 15 over 17. Last one, tangent of T. So write lowercase tan, capital T, and that is equal to opposite over adjacent. Opposite is 8, adjacent is 15, so that would be 8 over 15. All right, I'm going to erase and change this problem a little bit. I'm going to keep what are the sine, cosine, and tangent ratios for angle, and then I'm going to change this on you. I'm going to change it to the other angle, which is capital G. You can't go from the angle R, by the way. Angle R is the right angle. We would only set up trigonometric ratios from the acute angles. Okay, so I'm going to get you set up now. Sine of angle G equals, and I want you to try and write the ratio. Cosine of angle G equals, and then please try to write the fraction. Tangent of angle G equals, and then write the fraction. If you want even a little more help, I'm going to circle the capital G. I'm going to draw 3 arrows, labeling this one stays the hypotenuse, that's nice, but the 15 is now the opposite side, and the 8 is now the adjacent side. and that's because we're coming from angle G now. All right, so pause this video and try to write your 3 fractions. Welcome back. Let's see how you did. If you wrote sine of G is equivalent to 15 over 17, you got it right. That's opposite over hypotenuse, 15 over 17. If you wrote cosine of G is equal to 8 over 17, you got it right. That's the adjacent over the hypotenuse. And last one, if you wrote tangent of G is equal to 15 over 8, then you got it right. That would be the opposite side over the length of the adjacent side. Okay, so this slide right here is practice writing the equations. We're going to have one unknown in these equations, and then we'll use our algebra skills to solve for the one unknown. I can tell you right now, the unknown in these equations is the angle measure. So this is the unknown. What is the measure of angle T? And then this one in these 3 equations. What is the measure of angle G? That's the unknown. And I'll show you how to solve for that unknown angle measure. Just going to show you one right now. Might as well. Sine of G is equal to 15 over 17. So if our goal is to isolate G, then we need to get rid of sine. Well, how do we get rid of a sine? We've never had to do that before. Okay, well, let me ask you this. How do you get rid of a plus 5? If you said minus 5, you're correct. How do you get rid of a multiplied by 5? If you said divided by 5, you're correct. And that is because addition and subtraction are inverse operations. Multiplication and division are inverse operations. So, how do we get rid of a sine? We would have to use the inverse operation. And that is the inverse of sine, sine to the -1. So we would take sine to the -1 of both sides of the equal sign, and it ends up that G is equivalent to sine inverse of 15 over 17. We can then pick up our calculators. Sine inverse, mine is above the sine key, so I have to hit second first. So find your sine inverse key, hit second, sine inverse if you need to. And now 1,5, division sign, 1,7, close parentheses, enter. And I'm getting that it is approximately, I'll go to the nearest degree. So it's approximately 62 degrees. I should write approximately then. So by knowing that this was a right triangle and knowing at least 2 of the side lengths, we can find the measure of angle G, approximately 62 degrees. All right, a lot of information on that slide. Watch it again as much as you need to, or refer back to it when you have a question. Okay, next slide. If we know the sine, cosine, or tangent ratio for an angle, we can use an inverse. Okay, so this is what I just was sketching an example, but here it is much written up nicely for us. We can use sine inverse, cosine inverse, or tangent inverse to find the measure of the angle. For example, what is the measure of angle X to the nearest degree? Okay. All right, you guys, you can do this. Your goal is to find the measure of angle X, but we want to start by writing an equation with the letter X in it. I'm going to help you get started. Circle the X. Now I'm not going to draw 3 arrows this time. I'm only going to draw 2. And I'm going to label this one as the opposite and this one is the hypotenuse. I didn't draw the adjacent angle. I didn't draw the arrow to the adjacent side because I don't know the measure of the adjacent side. You could use the Pythagorean theorem to figure it out, but we don't need it. So let's just use the 6 and the 10. We only need 2 known parts. Okay, O and H. O and H. Oops. I need you guys to tell me which trigonomic function is dependent on O and H. If you need to go back a slide, rewind the video, then do it. Which trigonomic function? Your options are sine, cosine, and tangent. Which one of those three is dependent on O and H? If you said sine, you got it right. Sine of our angle measure is equivalent to the opposite side length over the length of the hypotenuse. Okay, so our equation with the unknown x in it is right here. Sine of x is equivalent to 6 over 10. Okay, you have written an equation with an x in it. We're now going to use our algebra skills to isolate the unknown. All right, this is the only unknown in the equation. S, I, and N, those are not variables. That's trig function. Those are not unknown variables. So to isolate the x, to make x the only thing on the left side of this equal sign, we need to get rid of sine. How do we get rid of sine? We use sine inverse. So we take sine inverse of both sides. Let me erase my scratch work there. So we've isolated x now. So the measure of angle x is equivalent to sine inverse of 6 over 10. All right, pick up your calculator. Let's type that in. Sine inverse. So mine, I have to hit second, sine. 6, division key 10, close parentheses, enter. And I get 36.8698 and so on. Rounded to the nearest degree, that would be the measure of angle x is approximately 37 degrees. All right. I want you to pause this video and try part B now. Welcome back. If you wrote your equation with an x in it as cosine of angle x equals 15 over 20, you got that equation right. Good job. Your next step would be to take cosine inverse of both sides of the equal sign. If you did that, it looks like this. Good job if you did. If not, just try to pick up how you would do it next time. And then if you typed it in your calculator and then rounded correctly and got approximately 41 degrees, then you got it right. Good job. Let me, for anyone who's struggling, let me give you a little advice. What is the measure of angle x? I like to circle the x, and I'm going to draw just the 2 arrows of the sides that I know. I then label those O, A, H, whatever's appropriate. The 15 it would be the adjacent side. The 20 is the hypotenuse. Now I ask myself, which trigonomic function, sine, cosine, or tangent, which one of those is dependent on the 2 letters that I wrote, A and H? And I know, or I can look back until I know, that it is cosine that is dependent on A and H, which is why we write our equation COS, then the angle, equal sign, the length of the adjacent side, the division bar, the length of the hypotenuse. Then taking cosine inverse of both sides isolates the x for us, and then typing cosine inverse 15 over 20 into our calculator, rounding to the nearest degree, is how we got the 41 degrees. So if you didn't get it, I hope you at least followed along with that explanation and feel like you can do it when you get to one like that in the homework or the next exercise you try. Before I end this video, I want to show you one more abbreviation. And you guys saw how there are so many abbreviations. This is like the most abbreviated possible, okay? It looks like this. SohCahToa. Think about that. What did the S, the C, the T, the O's, the H's, the A's, what do you think those represent? If you said S is for sine of opposite over hypotenuse, C is for cosine of adjacent over hypotenuse, and T is for tangent of opposite over adjacent, then you picked up on that abbreviation. Good job. A lot of people use this to help them remember the trigonometric ratios, and it is pronounced SohCahToa. SohCahToa. But you have to know how to spell it for it to help you. So something I used to do, and I suggest you do it as well, as soon as I'm handed an exercise in which I need to decide on a trigonometric ratio to use, I like to write SohCahToa at the start of the exercise, so that way I don't have to be memorizing, okay, sine's opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. I just have it right there for me to refer to. All right, and that will finish our discussion on section 9.3. My name is Jami Emigh. Thank you for joining me, and I will see you next time for our discussion on section 9.4.